Okay, so good morning. We're going to talk about surface area today, very last lesson that we're going to discuss in this particular booklet. So today, the surface area, we're going to look at first, before we dive into the examples, we're going to look at the formula first, so that when we apply it, when we go through the examples, we can figure it out. So when we look at this part here, rectangular prism, what kind of, how many surfaces does it have? How many surfaces does this have? So we know that we have the top, not top. Now, the area of the top is exactly the same amount of area at the bottom, right? Top and bottom would be the same, right? So if we have a rectangular prism, this is my rectangular prism, so the top will be the same area as the one at the bottom. So top and bottom. Now, how do we calculate the top? We know it's a rectangle. So the top would be width, this is the width, times length. Length and width. So you see that over here, length and width. But then you probably notice, like, oh, there's a 2 in front of it. So that means 2 times length and width. And the reason why it's 2 times length and width is because the area of the top is the exact same area as the bottom, right? So you just calculate top and then you double it. That's for the both top and bottom. Now what about the side? Okay, what about the side? So the side is a rectangle. It's length times height. The length times height. Okay, so that calculates that surface, rectangular surface there. Now, that's that part here, length times height. Well, why is there a 2 at the front? Why is there 2 at the front? So you look at 2 of them. It's exactly the same. So this is the side, right? So there's a right side, and then the left side, which we can't really see, it's somewhere over there, is the exact same area. Okay? And now what about the front? The front. So the front would be width times height. Width times height. So you look over here. Width and height, that will give us the front, but it's times 2 because the front and the back, we can't see the back right now, but it's right there at the back. They're exactly the same area. Okay? So here is the complete surface area of a rectangular prism. Okay? So we're gonna take a look. Okay, what shape do I need? Rectangular prism. So to figure out the surface area, it's gonna be, we're using recipe or formula. Now let's take a look at this one here. This kind of looks like our tent when you go camping, right? Or like the chocolate bar Toblerone, right? That's also that shape. So how do we calculate the surface area? Length times width. Length times width, that's this part here. That's actually the bottom piece. The bottom part of that, the tent. if we go here, width times height. Width times height, that's a triangle, right? Width times height is a triangle. Now, but there are two triangles in there. There are two triangles in this tent. So if we take a look at this, a triangle should be W times H divided by 2, right? Because that's the formula for a triangle. W times the H divided by 2. But then there are two triangles, so if we multiply by 2, the 2's cancel, and then we're left with width times height. The width times height. These two are the two triangles. Okay, so the width times height, that calculates the two triangles on two ends. And then the other one, L times S. Okay, well, what's S? What's the S? S represents for the slant length. S means for slant length. I'll just put that in here. S is a slant length. Slant length. So if we know what the length is, and we know what the slant length, the S, that would give us the area of just one of the side of the tent, one side of the tent. But how many are there? Well, there are two sides of the tent, right? So there's one side of the tent right here, and then on the other side that we can't really see right now. So there are 2 L times S. This one, all of these, talks about the two sides of tent. I'll just put tent because we know tent looks like that. Okay. So if we want to do the total surface area, all of the surfaces in that particular tent, that triangular prism, so you have surface area is equals to length times width. That's the area of the bottom. Okay, so if you're in the tent, that's where you actually lie down on the ground. The width times height, that's where the zipper of the tent is, right, to go out. Anybody here has never been camping before? You've never been camping? Okay. But are you okay? Like, I don't have a tent. I wish we could bring our tent if we have one. So this is where the zipper is. You unzip it and then you go out. Okay. So you got the two triangles, the front and then the back, and then the two sides. So that's that part there. And then. Okay. So far, so good. Let's take a look at square base pyramid. So how do we figure out the area of a square base pyramid? Okay, that's this one. Oh no, not that one. Do I even have a square base pyramid here? Oh yeah, I do. This is my square base pyramid. So if I open it up, what do we see? You have a square bottom, right? And then you have four triangles that folds up, make our pyramid. So here, the base here of the pyramid, that would be the base squared, b to the exponent 2. So I'm going to bring it back again, bring it back down. B squared. That's the base area. That's the bottom. And then B times,
Why is it squared?
hmm?
Why is it squared?
Why is it squared? Because it's B times B. B times B. Yeah. So B times B, that will give us B squared. Now, so B is the base, this length. Now 2 times B times S. Okay, well, why is that? Okay, let's take a look at that one for a second. So, you know, one of the flaps here is a triangle. So I'll draw one. Okay, so this is the B, and then this is the slant. To figure out one triangle, it would be base times S divided by 2, right? Whatever the base is times the slant height divided by 2. But we're gonna have 4 of these triangles in here, so times it by 4. So if we times it by 4, that's gonna tell us, oh, okay, 4 divided by 2 is 2. 2 times B times S. So that's where the 2 times B times S came from. So this part here, I'm gonna circle all of it. This talks about the area of 4 triangles. The area of the 4 triangles, the 2 times B times S. Yes? Okay. Now let's take a look at the cylinder. What are the surfaces on the cylinder? So when we open up a cylinder, we're going to end up with something like this. So we're going to have the 2 circles, and then we have this part here. It looks like a rectangle, right? Like a rectangle. Okay. So which part is which? Because they kind of look alike. So let's see here. The circle part is pi r squared. The circle part is pi r squared. So right there, pi r squared. But then it's times by 2. It's multiplied by 2 because we have the top circle and then the bottom circle. So that's why it's 2 times pi r squared. So if you take a look at this one here, this is the area of 2 circles. That's the area of 2 circles. And then this part here, 2 times pi times r times height, that's the body of the cylinder, right? This is the area of the body of cylinder. So when we open it up, it looks like a rectangle. So when opened up, looks like a rectangle. So this is the part where when we unravel, open up the cylinder, it looks like a rectangle to us. Okay, so 2 times par times h. Okay, so let's see here. Yeah, why is it 2 times pi times r times h? That's a good question, right? Were you wondering why it's 2 times pi times r times h? Are you wondering about that? Okay, I'll explain it. Have you had like a frozen juice? You know, like frozen concentrated juice you buy from the store? Yeah, you know, like you just add water to it and then that's your juice. So it looks like that, right? This part here when we open it up, okay, let's cut it open. Over here, this is called the circumference. This 2 pi r, right? So if your frozen orange juice is still circular, so this part here is 2 times pi times r, circumference. When you open it up, this is still 2 times pi times r. 2 times pi times r. And then this part here is the height. So now, what's the area of this part here? So the area is length times the width. So the length here is 2 times pi times r. 2 times pi times r. And the width is h. So that's why this part here is calculated as 2 times pi times r times h. 2 times pi times r times h. Yeah, is that okay? Okay, cone. Okay, now cone. Okay, here's a cone. So this one, if it's open up like this, that's the flat surface area of a cone. So we can see that there's a circle, one of them only, one circle. Whoops, I knocked my camera over, sorry. And then there's this kind of look like a fan shape. So
It was sunlight too hot.
yeah, it looks like that, the fan. Okay, it's a necessity for the summer. So this part here, pi r squared, that's the area of a circle. Area of circle. That's a circle bottom. And then the pi rs, that's the fan. I'm gonna put a quote unquote, the fan shape. That's the area of the fan shape. Okay, so we know the pi, the r, and then the s, the slant. Okay, and then last but not the least, I don't have a flat surface of a sphere. Oops. But I have a 3D shape of a sphere. So if we imagine this is a I don't know, an orange or an onion, right? This is an orange, perfectly circle, or an onion that's perfectly circled. All those onions are not perfectly circled like this, but if we take out the peel of this, that would give us a shape. And this is a formula for that. So 4 times pi times r squared. Okay. You know, before, like, I think a few years ago, I heard 2 of my students, way back, these are high school students, and they tried to peel an orange all in one peel. I don't know, have you tried that one before? Instead of peeling piece by piece, they tried to make it this like all peeled together, like they're all the pieces together, like none of them, and then they lay it flat. Okay, so that was a challenge. Like peel the orange without ripping any pieces. So that, when you think of it, that's the formula for that. Okay, so now that we're familiar with the formula, actually I'm gonna go back in here. I'm gonna put here top slash bottom. This top is the top and bottom. L times H, that's the two sides. And then this part here, that's a front and back. Front slash back. So we know which pieces are what, okay? So we can envision it. Okay, so far so good. Now, like I wanted to take that time because when we take time like that, we know why the formula is the way it is. So I'm gonna go backtrack to page 14. I'm gonna backtrack to page 14. We'll see how far we get to this part here. Let's see, page 14. Determining the constituent parts of the 3D object. Okay, so we know that a Kleenex box or tissue box is a rectangular prism. So what are the shapes to it? Okay, can we open it up? Open up the box, and what would it look like? How many parts would it have? Okay, so these 2 flaps here could be up here, it doesn't matter, or it could be in the second one. Depends on how you open the box, right? So that's a part. Okay. So when we open it up, let's examine the box of Kleenex shown below. How much cardboard would we need in order to make the box? In order to answer this, we need to calculate the surface area of individual parts of the shape. So these are the constituent parts. What size is this part here? 23. Okay, so this is 23. So this is 23. This is 23. This is 23. This is 23. How big is this piece? This is the 5. This is 5. Okay. How big is this piece? 4? Okay. Can we see this? It's 4. Does everybody agree it's 4? So this is the bottom piece of the box. Can you imagine? Okay, let's put that in our imagination. We're gonna take this piece and we're gonna start folding it up. We're gonna fold this up. So yeah, that's the 4. So that's this up there. Okay. How big is this piece? 4. Yeah, 4. Because this piece here, when it's folded up, and then this part here will also be folded up, and they should match. 4 and 4. So this is also 4. Okay. So we know that's 23. This is 23. This is 23. This is 23. 23. Okay, I'm gonna ask you this time, what's this size? Five? Why is it 5? Because yeah, so that should be the same thing as the bottom piece. So this becomes the top piece when it's folded up. So this one would be the side. That's the bottom, side, and top. And I should use the word front. Front. Back. And then this is the side. And this is the side. And then we can easily calculate the area of each part or each piece for this when we are able to draw them out like this. Okay. Let's take a look at, that be okay? This part here, what we're doing is just to draw the constituent parts, means constituent shapes or figures. So how, when you open this up in our minds, okay, what shape do we see to make when we open up this pyramid? What are the constituent parts?
4 triangles and 1 square.
Yeah, 4 triangles and then 1 square in the middle. Yes, excellent. And it looks like that. Yep, good. Okay, that's all we need to do there. What about this part? A cylinder. So when we unpack this thing or cut this up, the cylinder part, you know, rectangle, yeah, 1 rectangle, like that kind of reminds us of the like division sign. I don't know. Kind of reminds me of a division sign. So we have the 2 circles that kind of goes right, it's there, right? And then that's there. And then this part, when we cut it up and open it up, it looks like a rectangular shape. Now, what about this part here? Draw a constituent parts of a cylinder with no top. So how can we draw an object? Can you think of an object that's a cylinder that doesn't have the circular top? whoa, I forgot that this has water in it. If I take this, well, this is cylinder, right? For sure cylinder. If I take off the top, what's the surface area of this mug? Or this,
One triangle and one circle.
yeah, one rectangle. Yeah, rectangle. One rectangle. So it says here with no top, then it would just look like this. Looks like just a rectangular piece. And then the bottom. Because there's no top, right? No top. Okay? This is a really good thing because we're forced to getting the visualization of the shapes. Okay. It says here, draw the constituent parts for the cone. Can you think of an everyday object that's... What's the constituent parts of the cone? Looks like a... I'll go like this. It's like the fan, and then the circle bottom. So when you buy an ice cream cone, right, from a store, right, they have the wrapper. Right? They have the wrapper, and then there's also a wrapper on top, that circle that you peel out. So that's that piece. Next one. How can we do this piece? How can we draw this out?
Three rectangles.
3 rectangles. So this is going to be my bottom. And then this is the 2 side flaps. And then you got your triangles. Right? Okay. So now, like, those are really good ways so that we can visualize all of these shapes. Now we're gonna take a look at how to calculate the surface area. Okay. Is that good? Can we move to the next page? So we're on page 18 because we already did the 17. Example 2, determine the surface area of a cylinder. So this one here, if this is an assignment question or a test question, they're not going to tell us this part here, right? It's going to just show us this information. So it says here, a soup has a diameter of 8 centimeters and a height of 10 centimeters. Sketch the constituent parts of the soup can. Label the parts with the correct measurements. So, starting off with a 3D shape, a soup can, okay? Well, we know what the soup can looks like. Soup can. Okay. We're gonna say a soup can has a diameter. Diameter is this one here, from one end to the other. So D is equals to 8 centimeters. And then the height of 10 centimeters. Now we're going to take a look at the surface area of the can. Okay, what formula are we gonna use? What formula are we gonna use? So let's take a look. We know we want the surface area in a cylinder shape. So take a look. What formula are we gonna use?
Triangle and two circles.
The cylinder one, right? We're gonna use the 2 pi r squared plus the 2 pi rh formula. So 2 pi r squared plus 2 pi rh. Okay. So we figured it out. We figured out our formula. The next thing that we're going to do is substituting the values within the formula. Okay, substitution. So what are we going to put here? 2 times pi times r. Okay, r. Do I have r in this picture? No, we don't have the r. We only have the d and the h. How can we figure out the r? 8 divided by 2, right? We know the diameter is 8, so that means radius is 4 centimeters. Okay, so we had to divide by 2, so it's going to be 4 squared. Is that okay? Plus, okay, I'm going to continue on. 2 is 2 times pi times r. Okay, r I'm going to replace with 4 and then times h. H is 10. Okay. So what we could do is we could just put this in onto your calculator all at once, right? 2 times pi times 4 squared plus 2 times pi times 4 times 10. So let's do that. Okay, we got 351.86. Yeah. So 351.86, and then we're gonna put the area unit, the unit centimeters squared, right? Yeah. So far, so good. Yeah. Okay, let's take a look at oh, you know what? That's this part over here. Let's put that there because that's determine the total area. Sorry, we're gonna put that there. Just put an arrow down so that we can just say that's done.
That's the answer.
Yeah, that's the answer for B. We did the A and B all in one space. Just draw an arrow that we know it's for that one. Okay, now let's take a look at example number 3. Let's see. Calculate the amount of plastic needed to create a beach ball with a diameter of 15 inches. Beach ball, amount of plastic. So amount of plastic to make a beach ball, that's on the outside, right, of the beach ball. So this one tells us, I know it doesn't say surface area on the question, right? But then the amount of plastic, that's on the outside, that's on the surface. So what's a 4 squared? Okay, do we have the R?
15 divided by 8.
Yeah, 15 divided by 2. So that's, diameter is 15, so radius is 7.5. So 7.5 squared. Okay. So why don't you go ahead and calculate that piece? Okay, what did you get? What did you get for this one?
7,600.
So, whoa. Yeah. Good way to confuse people. Right, so 4 pi times 7.5 squared.
That'd be
706.86. Okay, inches squared. Inches squared. Okay, is that okay? Yeah? Christian, you okay? Yeah. Okay, next one, example 4. Find the surface area of a rectangular prism. Rectangular prism, a box. It says here, an online company ships its merchandise in insulated boxes measured 20 by 14 by 10. Okay, can we draw this picture so we have some kind of a visual? So how do we do that again? So right, slant, slant, and then so 20 inches long, 14 inches wide, and then the height is 10 inches. Calculate the surface area of the box. Surface area of the box. Okay. So how do we calculate the surface area? What's the formula? SA 2 times length times width plus 2 times width times height plus 2 times length and height. So what we're going to do is we're going to put this as L, that's our length, this is our width and height. So 2 times length, which is 20, times width is 14 plus. Do you like the brackets or do you like the X for multiplication? Or does it really matter? Doesn't matter, right? You like X? Okay, then do the X. Yeah. So 2 times width is 14 times height of 10 plus 2 times length, which is 20, height of 10. Okay, so let's calculate that. We're just gonna finish this off and then, so 20, okay, I got 1,240, and that's inches square, or square inches. Okay, is that good? Okay, so that we're gonna end there. Tomorrow we'll finish off the last examples, and we'll have time to work on the rest of these questions here.